Every theory of physics requires a foundational framework, a fundamental coordinate system that provides the coordinates where reality actually exists. Before matter can move or forces can interact, the physical stage itself must be strictly defined. Sir Isaac Newton established the architecture for classical mechanics in his 1687 work, The Principia. His central assertion was that space and time are independent entities, completely disconnected from the matter that inhabits them. This is the absolute stage. Space and time are rigid, unaffected dimensions that dictate where and when matter interacts, but remain entirely unchanged by the events occurring within them. To understand the logic of classical mechanics, we must first mathematically construct this invisible stage from first principles, stripping away all physical matter. We start with the axiom of independence. Imagine removing all planets, stars, and atoms from the universe. In the Newtonian model, this structural grid remains intact and immovable, even in a total vacuum. This spatial void follows the strict rules of Euclidean geometry. Within this grid, the shortest distance between 2 points is always a straight line, and the internal angles of any triangle will always sum to exactly 180 degrees. The second axiom is homogeneity. This means space is translationally invariant. The laws of physics function identically at coordinate 0, 0, 0 as they do millions of light years away. Every location is identical in its properties. The third axiom is isotropy. Space is rotationally invariant. The background has no preferred up or down. A physical interaction remains the same regardless of its orientation in the grid. Absolute space is a static, rigid container. It dictates the geometry of movement while remaining completely unaffected by the contents moving within it. We now turn to the dimension that governs sequence and progression, time. Newton defined time as an autonomous, one-dimensional stream that moves only forward at a steady, unalterable pace. This is the universal clock. Newton famously wrote that absolute time flows equably without relation to anything external. Because time is universal, 1 second measured on Earth is mathematically identical to 1 second measured near a massive star or on a fast-moving vessel. This uniformity creates the concept of absolute simultaneity. If 2 events happen at the exact same moment according to the universal cosmic clock, they are objectively simultaneous. Every observer, regardless of their position or velocity, must agree that those events occurred at the same time. In classical mechanics, time is not a subjective perception. It is a structural pillar of reality that binds all events to a single master timeline. To apply these rules, we need a way to translate events between an observer sitting still on the stage and an observer moving across it. We use Galilean relativity to link these different reference frames. Imagine an observer on a stationary train platform, frame S, tracking an observer on a moving train, frame S'. The moving frame's spatial coordinate, x', shifts by exactly x minus velocity times time. The perpendicular dimensions, y and z, remain completely unchanged by this motion. But the most significant part of the transformation is the fourth equation, t' equals t. This is the mathematical proof that time does not change based on relative motion. The clock on the moving train ticks at the exact same rate as the clock on the stationary platform. The Galilean transformation encodes the absolute stage into mathematics, rendering motion irrelevant to the passage of time. We can visualize this entire model as a theater stage. Space is the physical floorboards, time is the clock on the wall, and the actors, the matter and forces, interact without ever altering the stage itself or the speed of the clock. This axiomatic structure was remarkably successful, governing all known physics for over 200 years. However, as physics began to explore the extremes of the universe, cracks in the absolute stage began to show. Near light speed, or under intense gravity, time is no longer identical for all observers. The axiom that t' equals t breaks. In relativistic mechanics, space and time form a woven, dynamic four-dimensional fabric, warped and curved by mass and energy. While Einstein's work corrected the model for these cosmic extremes, it doesn't diminish the utility of Newton's work. The absolute stage, the rigid Euclidean grid, and the master cosmic clock remains a mathematically elegant bedrock that still accurately dictates the mechanics of our daily lives.